everyone. Just want to say tinakwe to the organizers of this event. You're doing great, and thank you for being you. Yeah, today, oh, that's a mic. Yeah, today I want to talk to you about Knative and what it is, and why it might be a useful piece in whatever you're trying to run. Yeah, let's take a look. Today what we're going to cover is what serverless compute is, Knative serving and how it affects productivity, and also some helpful patterns for adopting Knative serving. So yeah, thank you to GNS for helping me to be here, and yeah, if you're from Wellington, you're very familiar with them by now, or anywhere else in the country, but yes, hello everyone. So yes, I'm Caleb Woodbine, and my computer turned off. That's actually the title of the talk. Never use a computer, big mistake. Anyways, so yeah, I'm fortunate to live here in Wellington, beautiful city, very close by, great walk this morning. And yes, I'm a software engineer and platform infrastructure engineer. And some projects I've been a part of in the past include SafeSurfer, working on routers, and production infrastructure for DNS. And also at II, being a part of Kubernetes Conformance and Cikate's Infra. If anybody's running Kubernetes here, make sure that you're using registry.kates.io. Good reminder there. And I also really like building software that helps people to work better together or live better together, so that's one of my projects. Yeah, all right, let's on to the main question. What is serverless compute? It's something that allows you to focus and abstract what you're trying to do. So it often finds its way in web services or event-based connections between services. And you end up usually, if you're paying for it, it's something that is paid based on usage, so it's utility focused. Perhaps we'll have a look at some commercial implementations of this. So this only includes a few companies, but we have services like Google App Engine back in the day, and AWS Lambda, a few familiarities there, and also AWS ECS and Google Cloud Run. This one happens to be pretty relevant for the talk because it implements the same specification. Anybody writing 12-factor apps? Yeah, that's right. Do what they're doing. And 12-factor apps are really important because they allow you to run really fast with what you're working on and do things like separate configuration away from the actual application itself. Why is this going to sleep? And also things like your processes should be disposable. You shouldn't actually pour heaps of effort into a particular instance of a process. If you're doing that, please talk to me. We need to fix that. And yeah, really, really important things that will help you to scale really well. All right, let's start off with deploying an app on Kubernetes. This is a very concise example of running Nginx, for example. This one's got 3 replicas. It's got reasonably locked down. It's all great. Everyone's happy. Now we've got some internal load balancing. That's really important. We want to make sure that those replicas all get reasonably even traffic depending on what you'd like. Let's make sure we scale based on CPU usage. So, okay, maybe you're getting a lot of traffic, so we'll set a ceiling for that being 10 replicas. Maybe, I don't know, the nodes are kind of disruptive, but we want to really make sure that we have at least 2 replicas available. So you'd have a pod disruption budget. Let's have secure communication externally. Certificates are good. Want to make sure that you can actually talk to the outside world. So you'd configure your Ingress and your Ingress controller to do such things. And yeah, those are really important pieces. It's probably like around 100 lines of code, and that's all good. But maybe we can slim it down a little bit. So there it is. That's the slide. This is all you need, and you get all of what you just saw before. So yeah, all my key values here, check out the line that says name and the line that says image. So if you have a container image, It listens on a port. We want you. Come and hang out at. Yeah, this is really valuable because it's so concise and it does exactly the things that you intend it to. Here's a really powerful quote from Kelsey saying that your laptop should turn on when you need to use it. There's an option for this, isn't there? Yeah, so good. I love technology. Anyways, if Kubernetes is electric grid, then Knative is a light switch. So we're really scoping exactly what we want to take out of Kubernetes, which would be running serverless applications for this example. It's a project out of Google, like a lot of projects under the Cloud Native Compute Foundation. It was donated in 2022 last year. You can read the post here, check out the Knative website and repo over there. That's the logo. How cool and shiny is that? Doesn't it look cool? I want one of those. And yeah, let's talk about some features. So we've got some really useful features like scale to 0, which is, I mean, we're talking about serverless here. Let's not have it running when we don't need it. And yeah, so let's start off. OK, let's say there's something deployed, but nothing's accessing it. So this is what it looks like. And then, OK, let's make a request. I love curl. This is curl. And then, yep, let's check out what's running. We've got the pod was just launched, and your traffic was served. Isn't that awesome? Round of applause. No, I'm kidding. So that's great. And OK, let's say that delay has happened. We've timed out. No more traffic's coming through. We're just going to get rid of it, because why does it need to be running? So yeah, you can configure this, of course, if you're the platform team or you're doing your engineering there. And yep, that's great. Goes away. No more pods. We got rid of all of them. So that's good. Also, don't use the default namespace. This is for demo purposes. And yep, so all right, we've made some changes. We've got multiple revisions. Knative actually keeps track of all of your changes, and you're able to utilize multiple revisions simultaneously. And so for this example right here, we've got all of the traffic is at the latest revision being revision 3. And we'll talk more about this in a minute. So yep, here's traffic splitting. And we've configured the percentage to be 90% for the latest. So does anybody know how to use a computer? Oh, man. Was it caffeine? Yeah, there we go. Oh, man. Why do I use a computer? Anyways, and so we're doing 10% to the initial service that we created, and we're still using the same container image. By default, what it's doing is it's actually allocating domains, and we'll take a look at this. So you can have like a base domain, and then it will add the name of your service onto that base domain, which you're then able to access. And what this looks like is, so the snippet at the top is for the maintainers of the infrastructure. So they'd say like, OK, all of the services that we're wanting to run will go under this domain. So it could be like a company domain or something. And then you're able to make it so if the application deployers put in a particular label to their service, then it's able to go under a different domain. So we have 3 different examples at the bottom right there, which are all being served on different domains. Super handy. And yep, just explaining the label-based nature of it. And you're, as a platform team, you're also able to configure how those domains come about. So you're able to say, OK, we'll make all of them begin with the letter A because we're cool. And you can do that. But domain template's very handy. Internal by default is a nice thing. So kind of going with expectations. So I've just deployed a thing. I don't actually know where you want me to listen on or anything. And so this is what it will be by default. And you'd end up changing that. Moving on, we have the domains that people will probably more likely actually visit. So vanity domains, so like, I don't know, example.com. Any example.com users? No, I'm kidding. Great website, quality reads. So this is how you create the vanity domains on the CLI. So KN is a really cool command line interface for maintaining it. Still going to sleep, jeez. And yep, so that's how we could do that way. Or if we're wanting to put this in something that's managed by a CD system like Flux or Argo, then we can chuck this into the repo and then everybody's happy. And there's also like a trust layer to it. So let's say you've got your engineers deciding, okay, I want my, my front end to listen on this particular domain. By default, there's this behavior where the administrators need to approve that by creating a resource like this, although it can be automated and auto-approved for everything if you want that. So this is really handy, and that's how you do the automatic approvals. There's also the gradual rollout capability. And so what gradual rollout will end up looking like is, okay, I've deployed version 1, and that's all great and all, but maybe I want to deploy version 2, but I want to, let's give it a bit of time to make sure that everybody gets the latest version until it shows it's stable kind of thing. So that's really handy. And you can configure that as an annotation right here on your service, so that's super cool. And then you might have noticed in the earlier example, where's the port? Doesn't my web server have a port? This one does, which is great. You're doing something right if you're trying to bind to a port when writing a web service. But if your port is above or at 1024, then you'll get automatic detection for free. So less lines is good, isn't it? So another really great behavior is that you can configure auto TLS. So I think Cert Manager is an awesome project, and there's some great integrations with Knative. So if you're a platform engineer and you're trying to say, okay, I want automatic Acme handshakes to happen to make Let's Encrypt happen on my infrastructure for each service that's listening, then you can say, if you want a service, you also get TLS, which I think that's probably pretty good considering the effort, what it can normally be to get TLS happening. So this just makes it really simple, and you just don't really need to worry about it. There's some distributions of Knative that you can find out there that give you a minimum of, say, like 2 replicas or something. And so this is like a global configuration where you can actually say, I want for every service deployed there to be 2 replicas. Or you can actually set a ceiling of a maximum or of whatever you'd like. Yeah, so super handy. You can make it your service highly available by default, or you can make it so it scales to 0, like as per usual. And then another way you can configure private services. So maybe you're deploying something that you don't actually want to be on the public internet, which is like pretty common for a lot of things. Maybe it's a really important service that does things that, yeah, let's keep that not exposed publicly. Maybe it uses credentials or something. You can set up those private services that way. gRPC is also supported by using well, you don't have to declare it, but if you were to want to be super explicit, you can say the name of the port is H2C, which will kind of act as like a label, which is kind of a pretty nice use of how the components auto-configure themselves depending on the workload. And who uses latest? Like just no, don't stand. If you use latest, also I'm here to talk afterwards for emotional support. But yeah, so let's say, okay, we only use latest because of whatever reason. Knative has you sorted. If you push to the same container image tag multiple times, and you've actually updated the content, you'll have a different digest because this is how OCI tends to work. Well, it always works that way. It's the specification. And yeah, so it will automatically resolve your tag digest, and it will actually use that instead. So instead of using latest, no more. We'll use the other one. This is how the components of Knative are kind of laid out. So you've got a few webhooks, you've got a controller, you got this thing called activator, which is when you internally, it doesn't really matter, so internally there's the Ingress controller, which is supported by Knative, it's been pushed to Activator to say, okay, autoscaler, why don't you go and fire up a new replica so I'm actually able to serve traffic. And then you also have a proxy which lives alongside your application workload, which is able to then take the traffic, and it's also able to talk upstream to the other components to make sure that your workload is configured automatically in the right way. And there's actually not too many things going on there. I don't know how complicated it looks for a person who hasn't looked at this before, but I think it's pretty minimal considering all things. This is how the resources map. So you're probably more familiar on the right-hand side of this graph right here. Is it a graph? Diagram? There are words. And this is, I'll sleep again. And yeah, so you create services. I know service is such a loaded term, isn't it? Let's add more definitions, more things, and use the word service. But you create a service which, under the hood, creates routes, and it creates configurations, and it creates an ingress, which is understood by Knative, which ends up being mapped to other implementations that you don't really need to care about the ingress controllers anymore. And then you also have revisions, which it will end up creating a bunch of those. Goes down the chain, deployments, replica sets, pods, which is your actual workload. So that's fun. And about the components, you got Activator, which is queuing those requests and getting ready for auto-scaling, and then the auto-scaling, which is handled based off of Activator. And you also have the controller, which is actually taking your requests that are coming through and processing them and making them into the state that you want them to be in. And then the webhook, which will stop you from doing things that don't really make sense or try to help you with your requests. And then kproxy lives alongside your workload, and so it's a pretty small container which uses not that much memory or CPU, but it handles that kind of traffic there. Some common network layers, so in Knative, there's the word network layer. We don't really use it anywhere else in the Kubernetes space, but network layer like Courier, custom purpose-built ingress controller for Knative, or Istio. I really like Istio, so I use that. There's also Contour, which some of you might already be using as well. And there's some really cool security efforts. So Knative kind of considers itself like a platform, and so it's able to able to do some really interesting things to say, like, okay, you're trying to deploy something with Knative, so we're going to implement some best practices and things like that. So, for example, highly recommend adding secure pod defaults, which will end up adding this to your pods when they come up. And yeah, anyways, something. And then, yeah, so you have no privilege escalation and drop all capabilities, which means you can actually run your process as root if you really can't be bothered changing it, and it still can't do anything, because it kind of acts as a fake root. And then the security guard, which is a really cool thing, which is it's cutting edge at the moment, but it's coming along nicely. And what it allows application and platform teams to do is to be able to detect for misbehaviors in the application. So let's say I've deployed my Nginx process, and I don't know, someone's decided I'm going to exec into it because for some reason you still have a shell in your container. And so it will notice that, and then, OK, let's just kill that pod and then bring up a new one. So anything that they were trying to do is gone. So that's nice. And it uses an in-cluster model to train and figure out the normal usage of your application. There's also MTLS, vaguely service meshy. So if that's your thing, then definitely check out MTLS integration. There's an issue which is currently being worked on at the moment. There are some downsides. So cold start penalties can be things if you're already using like a cloud-managed serverless solution that you might already come into the whole thing of cold start penalties. And yeah, we only do HTTP-related things here, but that's the nature of this. Some positive side effects are, especially if you're using like a cloud environment, then you're able to be more on the greener side with the compute that you use. So if you use like a node cluster autoscaler to scale up and down based on usage for your nodes. Then based on the workload usage, it will also scale quite well, which is great. And it's also the same API wherever you want it, which is really valuable for anything cloud related because vendor lock-in does not help anybody. And in the wild, you'll find it under a few. These are just a few. There's a bunch more. There's Google Cloud Run, Red Hat, OpenShift Serverless, ChainGuard are doing a thing, IBM are doing a thing, Trigger Mesh are doing a thing. So if you want to buy it, you can buy it. How cool is that? Also some helpful patterns for adopting it. There's the operator, which I showed examples of. You don't have to use the operator. There's just config maps, same diff, who cares? You can put it in Flux or Argo, call it a day, happy infrastructure, running along nicely. Developers, run it on your laptops just like this. You can use Kind, Minikube, makes it super easy. Interact with KN like this, super easy. You've also got KN Func right here, which allows you to create really tiny boilerplate code, which transforms into these Knative services really easy. So this is a stupid simple example. And yeah, it's on GitHub right here at Knative as the org. And it's community driven, and I'm a contributor, and I would say the people there are pretty cool. And you can be a part of this as a standard. The specification is all on there. We need more contributors, and I reckon New Zealand contributing to more CNCF projects would be really awesome, and I think it's shown me a lot of value in the things that I've been up to. Do we have time? We've got 2 minutes. Okay, let's see if we can do a little demo. Oh, 2 microphones. How cool is that? Ah. So this is a terminal. Amazing. So, all right, let's just deploy something. Crazy how fast I typed that out, eh? Anyways, oh, what do you know? We got a thing. How cool is that? And let's just access it. So, I don't know where this will open, but if I click it, maybe it will open. Can someone please pray to the demo gods, please? Oh, there we go. Very cool. You can't see it, but it says hello. Now you can see it. How amazing is that? Great. It's nice when you can find the mouse, isn't it? All right, and then we'll go over to here, and I just ran another command. Amazing. So that just has listed the revisions. That's great. Let's deploy V2 because I think we're ready to hit production, and like I don't know, sales are going really well. Cool, we got V2. So if we go back to this one, refresh. Hello V2. Who's surprised about the change there? And then next, got 40, 45, 44. 40. Yeah, I'm counting down the seconds. Cool, 2 revisions, amazing. Let's do a 50-50 split. Great, that's done. And then I just keep hitting Command R. There we go. How cool is that? Wonderful. And let's do it again. You'll notice traffic 50-50. You can do describe to your heart's content. You can curl it using curl because that's what curl's for. And let's do V3. It's time. We're ready. Production. Come on. Yeah, V3. How about that? And let's set the traffic to 100%. And that's my talk. Thank you, everyone.